All right, moving on with our systems of equations with three variables, we've got elimination. This method is best used when each equation has all three variables. Let's see if we've got an example around here anywhere. Ah, here we are. We've got x, y, and z, three variables in three different equations. Perfect. To solve these types of systems, we're going to use the same elimination tactics we used before to slowly eliminate our variables until we can solve for one, plug that back in, solve for another, so on and so forth, so on and so forth. Mission 1, we want to choose a variable to eliminate first. Alright, now you can choose either x, y, or z. You'll kind of get a knack for finding out which one is going to make the problem easiest. Remember, we want the coefficients of the x, y, or z to multiply to cancel with another equation. I'm going to go ahead and pick y because I see that this minus 2y could cancel this plus 2y. And then I know if I multiply this y by 2, I could also match it up with these other equations. Mission 2, eliminate the y twice to get two new equations. Again, you could have picked x, y, or z. I went ahead and chose y. So here's what we're going to do. I'm going to go ahead and match up the first equation and the third equation because I see if I add these together, this y is going to eliminate. Just like this. X minus 3x is negative 2x. Negative 2y plus 2y. Those are eliminated. 3z minus 2z gives me a positive z, and 7 minus 10 gives me a negative 3. I want to take this equation here and stash it for later. Alright, we've got one equation stashed, but remember, we want two new equations. So this time, I'm going to go ahead and do this. I'm going to multiply this second equation by 2 and get 4x plus 2y plus 2z equals 8. Then I'm going to match that up with this first equation. Now you'll notice that we've got a negative 2y and a positive 2y, which is going to eliminate that y term just like we want. Now I chose the first equation. You could match any of these equations with each other so long as you can eliminate your variable. Doing that, we're going to get x plus 4x, 5x, minus 2y plus 2y. Those are going to go away. 3z plus 2z, 5z, and 7 plus 8 equals 15. Let's take that equation and stash it for later. Now take a closer look at our stashed equations. We've got 5x plus 5z equals 15 and negative 2x plus z equals negative 3. Two equations with two variables. That brings us to mission 3. Choose another variable to eliminate. Here, looking at this, I can see that if I take this first equation, set it up with negative 5 times the second equation, that's negative 5 times negative 2x, 10x, minus 5z, plus equals positive 15, and I match those up and add those two equations together, we'll get 15x equals 30 or x equals 2. Dun, 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 we've got our first variable. And you've made it to the fun part. Take that x equals 2, plug it in, and solve from there. That'll give us negative 2 times x, or 2, plus z equals negative 3, and a z value of 1. I chose to plug that x into the second equation, but you could have plugged it into this first one as well. Now we've got x equals 2, z equals 1. Let's go back to our original equations and choose one of these guys. Choose one of these guys to plug it into. I'm going to go take it and I'm going to plug it into the first equation because it looks like a mighty fine choice to me. Plugging those in, we're going to get 2 minus 2y plus 3z, 3 times 1, equals 7. Solve from there, and we're going to get y equals negative 1. And great Scott, we've got our answers. X equals 2, y equals negative 1, and z equals 1. If you think you've messed something up, just take these variables and plug them back into these equations. You should get true answers confirming that you've successfully solved the system. Tips for doing this: take your time. Be careful. If you make a mistake, it's a whole lot of work to just start the problem over. I've learned that the hard way. All right, I'm done.